Hello, I wanted to go through the quiz 5 that you took last week. There were some requests and I know that some of you expressed some questions and confusion on it, so I thought I would use one of the videos to go through it. First question asks for how high an object rises if it's launched straight up from the ground with an initial velocity of 10 meters per second. As I talked about in class, it's important to know what we're looking for, and I would call that y final. That's this term here, y final. And know what we have. We have the initial velocity and we have the final velocity at the very top. So initially it's launched at 10 meters per second, but at the very top of the trajectory it's going to stop ever so shortly for just the briefest time at the very top. So the final velocity in this case is the velocity right at the top, which in this picture down here that I drew on this graph be right at the very top here. That's going to be 0 meters per second because that represents it stopping for just that instant. So then I used this equation here. It's the third free fall kinematics equation. I replaced what was 0 with 0. So v final is 0 and y initial is 0 because I'm launching it from the ground. Then I'm left with this expression, v initial squared minus 2g times y final is equal to 0. Then I solve that for y final. So y final becomes equal to the initial velocity squared divided by 2 times g. If you plug the numbers in, 10 squared is 100, divided by 2 times 10 divided by 20 gives you a final height of 5 meters. And you see I put that in the graph down here. That represents the final height, where we're taking that to be the final position for the moment. Remember, the final position depends upon what aspect of the problem you're interested in looking at. In this case here, we want to know for question 2, how long does it take to get to that height? Well, now we know the final velocity, or we knew it already, and we know the initial velocity, so I can just simply apply that to the second kinematics freefall equation and then solve for time. So I plug the 0 terms in. 0 is the final velocity, so 0 is equal to the initial velocity minus g times time. Then I solve for time by subtracting the initial from both sides and dividing by minus g, and that's what I get over here. And if you cancel the minus signs, you'll get that time is equal to the initial velocity divided by g, and that gives you 1 second. Question 3 is, how long does it take the object to fall back to the ground from that height? Well, in this case, because it's being launched and landing from the same height, we know that that's going to take 1 second for that to happen, to get to the top, and that because they're the same, it should also take 1 second for it to land by symmetry. You can apply symmetry when it launches and lands from the same height, and it does that in this case. If you chose not to apply symmetry or didn't realize you could do that, one way to do this would be to figure out how long it's going to take to go from this height here, the initial height, up and then back down to the end there. And in that case, I would say the initial height is 0 and the final height is 0. So if I plug that into the first kinematics freefall equation, these two terms are 0, I get that v initial times time minus 1/2 gt squared is equal to 0. I could then bring 1/2 gt squared to the other side and see that v initial times time is equal to 1/2 gt squared. And then plug in v initial, which is 10, and g, which is 10. And I would find out that there's 2 roots to that. One of the roots is 0, and the other one is 2 seconds, or 2 times vi divided by g, 2 seconds. So it takes 2 seconds to go all the way here. And if it only took 1 second to go here, it takes another second to go from the top here down to the point where it lands at a total time of 2 seconds, or a time of 1 second from the peak to where it lands. Then, of course, graphing it. We've been talking about this first graph of position versus time. For the other parts of the problem, it's a parabolic function, as you can see, with a maximum height of 5 meters, initial height and final height of 0 meters, and at 1 second you're at the peak, and at 2 seconds you've landed. The velocity versus time starts out at plus 10 meters per second, goes to minus 10 meters per second at 2 seconds, because it has to be the opposite of this because of symmetry, and it has to have a slope of negative 10 because that is what the acceleration is, negative 10 meters per second squared, because it's under free fall. So it would be constant negative 10 meters per second squared for 2 seconds. Okay, I hope you found this